All right, this is AP Calculus, Unit 3, Lesson 6. We are on our new standard I, and I'll ask you what that is in a few seconds. We are on analytic analysis, finally, and we're talking about things that we already kind of know, when the function is increasing, when the function is decreasing, and where those critical values are for the function. So, standard I, what is that?
Are you recording?
Yes.
Are you sure?
Yes.
Show the thingy.
Oh, is this, I think the screen is still frozen.
Oh.
All right, so, standard I, what is that?
I told you.
Standard I, standard I.
I've never understood these standards.
Standard I is analytic.
Analytic analysis.
Analytic analysis, there it is. Thank you, Rosalie. All right, so analytic analysis. So now we're actually going to be giving you an actual function. I'll say f of x is equal to something, and you need to tell me where the critical values are. I'm not giving you a graph anymore.
Okay. I don't feel like it. Fine.
All right, so 4 easy steps. So first step is to draw our x-axis, then find, what are the CVs again? What does that stand for?
Critical value.
Critical values. Where do critical values happen?
Where it's equals 0 or d and e.
It's not it, but
F prime.
f prime is 0 or
My bad.
d and e.
Suck, Carly. That's what you just said.
Yeah, you just like bursted my bubble.
I'm sorry, but you got it right, d and e and 0.
But did you?
Last time I tried.
All right, then we test some points in between where we found our critical values, and then we come to our conclusion. Everything is going to be marked up here on the right. So let's go ahead and follow these steps with an example. I'm feeling like, I'm going to go to number 1.
Nobody ever asked me how I feel.
How do you feel, Rosalie?
Just confused. Everything.
All right, I'm going to tell you that f of x is equal to this is going to be, actually I'm just going to go ahead and tell you f prime of x. I'm not even going to take the derivative. I know that we can do that. F prime of x is equal to negative 3x. I've already taken the derivative for you. So the actual function when I'm not taking the derivative is quadratic, but the derivative here, I guess, if I drew the graph of the derivative, it would be a straight line, yes. All right, so this is example 1. So I'm going to do step 1 now. I'm going to draw my x-axis. I'm going to draw it down here a little bit because we need to write some stuff above and below it. All right, I drew my x-axis. All right, how do I find my critical values?
Graph it? You gotta graph it first, right?
You can do it without graphing it because we had the definition of critical values, right?
0 D and E.
Yeah, so how do we find where those x values are for where f prime is equal to 0? Well, we set f prime equal to 0. So I'm going to say 0 equals negative 3x. I'm just using the definition. I say f prime is equal to 0. I changed f prime to 0. And then I solve. 0 equals negative 3x. Therefore, x is equal to?
Negative
0.
0. Thank you.
Oh, 0.
All right. And then, is there anywhere where this function does not exist?
No.
No, so we don't worry about it. So d and e, we can write d and e over here. Don't worry about it. Don't worry about it.
Do not even worry.
Because usually d and e is where you're going to have a fraction, something in the denominator, and then we have to worry, but we don't have a fraction. Okay, so whenever I have a critical point, this is really important. Make sure that critical point is with a tick mark. So let's make a tick mark right here. This tick mark is going to represent a critical point, or critical value, sorry, CV. CV. And I'm going to label it underneath here, 0. So whenever I do a tick mark, critical value. And maybe we can even say here, tick mark. And maybe you don't like writing out tick mark. Maybe you'll just say, whenever I have a number line, this thing here is going to be a critical value. Nothing else. Don't make tick marks for your test points. Only tick marks for critical values. So this is going to be our CV. I can even label it over here too. This is our CV. And now I need to choose test points. I'm on step 3 here. by test points, I just mean choose something to the left or to the right of your critical value. So what's an easy number on the right that we can
One.
look for? 1. All right, so I'm not going to make a tick mark, but I'm going to say I'm going to choose 1.
I'm so used to that.
Yeah, you can't make a tick mark anymore. You can make a little point if you want, but I would recommend not writing anything. So if I choose 1 and I plug it into f prime because I'm testing f prime, because this is the f prime test, plugging in 1 gives me a negative or a positive.
Negative.
Negative. So when f prime is negative, is that increasing or decreasing?
Decreasing.
Let's label that. Decreasing. Let's get another test point to the left. What's a good number to plug in?
Negative.
Negative
1,
one.
okay. When I plug in -1, is it positive or negative?
Positive.
And f prime is positive, so is that
Increasing.
increasing? Exactly, increasing. And then maybe we can write, when I plug in -1, I get increasing. So increasing, maybe we can write a little plus down here, and it's decreasing, a little negative below that. And that leads us to our conclusion. Our conclusion is that it's increasing before critical value, and it's decreasing after that critical value. So if I were answering a question, the question would have been asking, where is FCV? Where is F increasing? And where is F decreasing? Okay, where is F critical value? Where is the function's critical value?
0.
What equals 0?
F.
X is equal to 0.
That's what it meant.
At the value of x equals 0, remember this is our x-axis, we could have labeled that too. When x equals 0, we have our critical value. Okay, now I need some intervals. Where is f increasing?
-1.
It's increasing at -1, but it's also increasing at -2, -3, and
Infinity.
so negative infinity, yep, all the way to the left. And then where does this end?
0.
0. Does it include 0 or not include 0?
Not.
No.
Nope. All right. And then f decreasing, where does that happen?
Infinity.
For 0 to
Or 0 to infinity.
Yeah, you guys got it. 0 to infinity. Perfect. Why is this a parenthesis and not a square bracket? Why is it not including 0? Can someone explain that to us?
Because the slope's 0 right there. It's not an increasing slope.
Or
That's well said, yeah. It's 0. And in order for it to be increasing, it needs to be
Positive.
positive. Exactly. And 0 is neither positive nor negative. It's in the neutral ground. Let's try our second out of 3 examples. So I'm going to go to our next slide. Are we all ready? Set. All right. So this is our second example, number 2. And I guess I should label these all examples.
I need to buy tie-dye stuff for our shirt.
This is true.
Did we get extra small?
I asked, and he said the smallest they had is small.
I think it'll be fine if you want to put it. Oh yeah, I don't think you
Let's try negative x squared plus 4. All right. So now try to do this without looking at the steps. Now we're trying to remember what those steps are. What was our first step? Do we remember?
Figuring out.
Draw an x-axis.
There it is. Draw the x-axis.
I didn't look at them.
What was our second step?
critical
Yeah. Find the critical values. Where are the critical values in general?
So this is a quadratic.
This is a quadratic, yes. Which means the actual function when I don't take the derivative is a...
Linear.
Going backwards. That means the power is increasing. Yeah, it's a cubic. Is it going to be a negative cubic or a positive cubic? Sorry.
Negative.
Negative, you're right, because this was a negative quadratic. So from here, I need to find critical values. How do I find critical values again?
setting f prime to 0.
Yeah, setting f prime to 0 or finding where it does not exist. So in this case, I'm just going to say 0 is equal to the rest of the equation. I'm setting it equal to 0. Negative x squared plus 4. And solve. Maybe I can move this line a little bit down so I have room to solve. when I solve this, what happens? I'll give you guys 30 seconds to solve this on your own. Make sure we remember our Algebra 1, Algebra 2 skills. All right, I'm going to silently do this on the board. All right, go ahead and check on the board. Give me a thumbs up, thumbs down. Did you get both answers?
No, I only got one.
You forgot the plus or minus? Yep, so whenever you take a square root, it can be either or. Plus or minus. All right, so let's go ahead and mark those on our x-axis. This is our x-axis. So I'm going to say -2, tick mark at -2, a tick mark over here at 2. All right. So we just did step 2, which was find critical values. What's step 3?
Test points.
Test points, yeah. So where's a good point to test on the left over here?
-3.
-3. Maybe I should do that in a different color because they're not critical values. I'll say maybe red is my non-critical values. What about in between -2 and 2?
0.
0. And what about greater than 2?
3.
I like all these numbers. Those are the same numbers I would have chosen. I think those are the easiest. So what I want you to do now is draw a conclusion. Figure out if it's positive or negative, draw that underneath with a circle, and then tell me if it's increasing or decreasing on the top of the number line. Do that now. In about 20 seconds, I'm going to silently start solving this on my own so you can check your work. All right, answers are up on the board to check. Thumbs up, thumbs down. Did we get these values?
I'm confused.
Oh, you got 1 2.
All right, so I'll talk about this then. When I plug in -3 into my x squared, what do I get?
Oh, shoot.
Wait, what?
When I plug in this -3 into my original equation of x squared, what do I get? 9, and then add the negative, so I now have a -9. What's -9 plus 4?
Oh, that's where I went wrong.
Did you forget the negative, or did you forget
I
to?
forgot the negative.
Okay,
The other negative. I thought it turned positive.
cool. So negative means it's decreasing. When I plug in 0, 0 squared is, shout it out.
0.
-0 is 0. Plus 4 is 4. 4 is positive, therefore increasing.
What was the first? What was the answer for the first one when you test the point?
This point here,
Yeah.
I think we got -5. A negative number. We only care about if it's negative or positive. So maybe we should write that on the side. When testing points, I'm not going to say we only care about and I don't know how you guys want to put it in your notes. Maybe you want to do a negative sign with a circle, or you want to write out negative. For my notes, I'm going to say negative and abbreviate, or positive. Not the value. All right, and then just testing this test point. So when I plug in 3, 3 squared is,
9.
and then a negative 9. So negative 9 plus 4 is
-5.
negative 5, which is a negative. Again, we only care about if it's negative or positive. And negative means what type of interval? Increasing or decreasing? Decreasing. Perfect. All right, so then again, we have those 3 same questions that I'm going to be asking every time. Where are the function critical values? In the function, where is it increasing? And in the function, where is it decreasing? All right, what are the answers here? Critical values. Yep, where x is negative 2 and 2. Where is it increasing?
Between negative 2 and 2.
Between negative 2 and 2. Is it including negative 2 and 2 or not including? All right, so negative 2 to 2, not including them, so parentheses and not square brackets. And where is it decreasing?
-3 to -2.
Careful here, because technically we go all the way out here to,
Oh yeah, negative infinity to -2.
yep, so it's going to be negative infinity to negative 2. And then when I have 2 of these, I usually write the or in between, which is sometimes you can write an or like this or like this. These both mean or. And it's whenever you have many different intervals. You might have seen it in the answer keys. And then the second interval is where to where?
2 to infinity.
2 to infinity. All right. Everyone's, and one last example. Here we go. Example 3. Did we even label the last example? That was example 2. This is example 3. All right, so this time you're going to have to find your own derivative. I'm only going to tell you f of x, and that is going to be equal to 1/3 x to the power of 3 plus 2x squared plus 4.
What the heck?
I need to know by the very end of this, where are the critical points, critical values for the function? Where is the function increasing? Where is the function decreasing?
So, I don't know how to do the first part because, let's see, you have a cubic, quadratic, and a constant.
So whenever you're looking at just the function, you take the highest power, and that is, this whole thing is a cubic. Well, that's not quite true. I mean, it is technically a cubic, but I think the best way of explaining this one is it's just a polynomial function. It has many different things in it. So we don't really care about classifying him as much as just taking the derivative and then analyzing him. Because this is no longer graphical analysis, but that's good that you're always making that connection. What I care about most is taking the derivative and doing all the steps that we just did earlier today.
So, are you going backwards like we did on the last one and doing a quartic from that?
No, I'm not going backwards at all. I need to find f prime. I need to take the derivative, f prime of x.
So it'll be x squared plus 4.
And then from there you solve?
And then from there, do the same process that we're doing earlier. So go ahead and try this on your own. Look up at the board when you need some help or want to check your answers. Ooh, I'm gonna pause right here because I feel like this might need a little bit of review. But if you know how to do this, keep going.
You're at -4.
That is one of the answers. Yep.
Okay.
All right. I like to have the whole class think about the problem when I get to this step. What do I do when I have 0 is equal to, and then I did the factorization of x squared plus 4x and pulled the x out to get x times the quantity of x plus 4 n quantity? What do I do here? What's my next step?
Sorry.
So once I get to this step right here in this factored form, what do I do in order to solve for x?
You have to factor? Why can't you just plug in 0 for x?
Because that will only give you one of the answers.
Oh, poop.
You have to factor it and find out exactly what those values for x are. You're actually solving here. So I'll give you the answer here. Review is, this is the zero product property. Do you remember the zero product property?
Yeah, so then you plug in 0 after you've done that.
Not exactly. This turns into two problems. The two problems are this thing is equal to 0 or this thing is equal to 0. Whenever I have two quantities, A and B, and when I multiply those two quantities to get 0, that means this implies A equals 0 or B equals 0 or both. Which means I need to set this whole quantity, if it's x plus 4 or something even bigger, this entire quantity, A needs to be set equal to 0, and this entire quantity, B, needs to be set equal to 0. So you should get 2 critical values out of that. All right. Did you guys make your tick marks on your x-axis already?
Yeah.
What are you guys using for test points? Are you using the same ones as me or different ones?
I'm still trying to get there.
Okay.
3.
You could use -3 if you want to do in between here and here. Yeah, you can use any values that you want.
So it doesn't really matter, does it?
It doesn't matter as long as you make sure you're in between the intervals. Like an incorrect idea would be, oh, I'm going to use -3 over here, and that's not going to work because this goes towards negative infinity. All right, so what happens when I plug in -5 into my original equation for f prime? Remember, you always go into f prime when I'm plugging in values because this is the graph of where I have increasing and decreasing. Definition of increasing and decreasing is what?
Can you say that again? Sorry.
What is the definition of f increasing? It's where what happens?
Where it's going up.
Positive.
Positive.
Where what's positive?
F prime.
Exactly. That's why we want to deal with f prime and not f. So, plug in -5 and see if I have a positive or a negative value.
It's 20. I mean, it's 5. Sorry, it's 5.
Positive 5 or -5?
Positive.
It is +5. Therefore, it's increasing. What happens when I plug in -1?
How did you get
Negative
Positive 5. How
Negative
did you
three.
get positive 5?
How'd you get +5?
-3.
It is -3 here, so that's a negative. But let's go ahead and ask the question, how do we get 5 here?
You plugged in -5 to the top, you put to F, the equation of
Yeah, so let me do it on the side here. When we plug in -5, we get -5 quantity squared plus 4 times -5.
Oh,
-5 squared is
Okay.
25 minus 20, and we got a +5, therefore positive. plug in -1, see what you get. Isabel already did that and found that it was a negative. See if she was right. And Isabel, go to the next step. Go and plug in 1. So Joy, did you get a positive or a negative when you plugged in 1?
Wait, what did one?
Yeah,
It's a positive.
positive. All right. I'll wait to make sure that we can all get there.
I got it.
All right, so if this gave us a negative value, therefore this interval is what? Increasing or decreasing?
That one's decreasing.
And then our final interval,
Increasing.
increasing. All right, so now we need to answer these questions. Where is f? Where is the critical value of our function?
-4 and 0.
So it's x equals -4 and 0. Someone new? Where's f increasing?
Infinity to -4.
Careful there.
Infinity.
Yeah, there it is. -infinity to -4.
0. Yeah, 0 to infinity.
Or 0 to infinity, exactly. And where is f decreasing? Someone aside from Rosalie and Carly?
-4 and 0.
Between -4 and 0, not inclusive. Perfect. Yeah, I think you guys are ready then. Go ahead and write your summaries. That ends this lesson.